Okay, so L'Hopital's rule. L'Hopital's rule says, okay, so when we do a limit, any limit problem, on the board, I'll put an easy limit problem. Actually, you know what? No, let me put it on here so we can see it. Let me put an easy limit problem that you guys can do easily. So let's say we have you don't have to write this down, but let's say we have a limit problem that looks like this. How do we solve that limit? What's the process for solving that limit? Plug it in, right? Plug it in. And if it gives you an answer, -2 is an answer, right? We're done, right? That's the easiest way to plug in a limit, right? Well, what L'Hopital says is, do that. And when you do that, if you get an indeterminate form means one of these two guys. Most likely 0 over 0. So why is 0 over 0 called an indeterminate form? This is why. You're taught from junior high on probably that if you have a fraction, and you have 0 on top of the fraction, what is the answer always going to be? 0, right? And you're also taught that when you have 0 at the bottom of a fraction, what's that going to give you? Undefined, right? It's going to give you undefined. If 0 is on the bottom of a fraction, like 12 over 0, can't do that. Calculator will say error, right? Because how many times can 0 go into 12? Well, can't, because it's 0, right? So you're taught that anytime you get a 0 on top, the answer is always going to be 0. Anytime you get a 0 on bottom, the answer is undefined. Well, how about if you get 0 over 0? Is it 0? Is it undefined? The answer is, I don't know. It's indeterminate. We don't know. Is the answer 0? Is the answer undefined? I don't know, right? Let me show you a calculator. 4 divided by 0, undefined. 0 divided by 4, 0. So if I get 0 on the bottom of a fraction, it's always going to be undefined. If I get 0 on top of a fraction, it's 0. But what if I get 0 in both places? Is it 0? Is it undefined? The answer is I don't know. That's why we call it an indeterminate form. Indeterminate form. I don't know what it is. I don't know what the answer is, so that's why we call it's indeterminate. Okay? The other one is infinity over infinity. See, a lot of people see infinity over infinity, and you think the answer is, 1, right? 1. The same number over the same number. But infinity is not a number, right? Infinity is not a number. It's an idea, right? It's an idea. Somewhere out there on the positive side that we can't even see how far it is out there. Or reverse, on the negative side, right? It's so small that we can't even see the number. We don't know what infinity is. It's an idea, right? So we can't divide an idea divided by an idea because they're not numbers. We can only divide numbers, right? Positives, negatives, decimals, fractions, whole numbers. So that's why this guy is also indeterminate form. We don't know what it is. We don't know. Okay, so it says, so the way to do these is find the limit. Okay, so let's do number 1. The way we've been doing it since August. Plug in 2. See what happens. Let's see what happens. So 2 squared is 4 times 3 is 12 minus 14 plus 2. 2 minus 2 is 0. So we're going to get 0 over 0. Indeterminate form. I get 0 over 0. So what L'Hopital's rule says is if you plug in, is if you use substitution, plug in the number for the limit, and you get an indeterminate form, instead of having to use all of those things that we did last in August, the easier way to do it is just say, hey, take the derivative of the top, take the derivative of the bottom, and then do the same thing, plug it in. Okay? So normally what we'd have to do, last semester, this is what we'd do. I would factor this guy. I would factor this guy and see if it cancels out. But L'Hopital says you don't have to do that. Try this step. Take the derivative of the top. So that's 6x minus 7. Take the derivative of the bottom, which is just positive 1, right? Repeat the process. Plug in 2 now. Now when I plug in 2, I'm not going to get undefined. I'm going to get positive 5. Which is the same answer I would have gotten last semester. But now that we know how to find derivatives, it's a little easier than having to factor. Right? It's a little easier than having to deal with those. The things we did last semester in August, they worked, but this works a little faster. Okay, because you guys are so used to finding derivatives. You guys know how to find derivatives. We spent a whole 3 months, 3+ months, figuring out how to find derivatives, right? Okay. Okay, so let's look at number 2. Same thing. Let's plug in 0. Or plug in, sorry, -3 for this one. So -3 plus 3 on top. -3 squared minus 5 under the square root, and then a -2 on the outside. Order of operations. Nine minus 5 is 4. The square root of 4 is 2. So 2 minus 2 is 0. So we get 0 over 0. Anytime we get 0 over 0, that means we can use L'Hopital's rule. Okay? Anytime we get 0 over 0, that means we are able to use L'Hopital's rule. So L'Hopital's rule says find the derivative of the top, find the derivative of the bottom, repeat the process. Okay, so let's see. Limits. So the derivative of the top, x plus 3, just 1, positive 1. The bottom, I'm going to have to do, I'm going to have to move to the side here because that one is a root. Right? A root means 1/2 power. So that one I'm going to use the chain rule. So you know what? Let me change the color so it doesn't blend in with the other stuff. So derivative of, we're going to use the chain rule. So we move the 1/2 to the front. Everything on the inside stays. We subtract the whole power. So 1/2 minus a whole is -1/2. So I'm going to put that guy back in. And then the derivative of minus 2 on the bottom, minus 2, the derivative for that guy is just going to be 0. Okay. Only one place to plug in a negative. Yep.
Do you have to take the derivative of the inside?
Oh, sorry, yeah, Fred, do that, yeah. I totally missed that part. So the derivative of the inside would be 2x. Yeah, thank you. Okay. Plug in negative 3. Okay, so negative, let's see, 1/2. Negative 3 squared is 9. 9 minus 5 is 4. So I get 4 to the 1/2 power times negative 6. Oops, not 1/2, negative 1/2. What is 4 to the negative 1/2 power? It's so the answer, so 4 to the regular 1/2 power. So what does 1/2 power mean? So this is what I'm trying to find. What is 4? So what is 4 to the regular 1/2 power? It's square root, right? So it would be 2. Now what does the negative mean to do? Flip it, yeah. So it would be 1/2. So you get 1/2 times 1/2 times negative 6. Well, 1/2 times 1/2 is 1/4. Times negative 6 is negative 6 over 4, which reduces to negative 3 over 2. So I have 1 divided by negative 3 over 2. Keep, change, flip. Keep the first one, change the multiplication, flip the second, and I get negative 2/3. Okay. The part about that took us the longest was just order of operations. That's the part that took us the longest. It wasn't the calculus part. It was just the order of operations part. PEMDAS. Okay. All right. So let's look at number 3. Number 3 is a little bit longer, but we're still going to do the same thing. Plug it in and see what we get. Always when you get a limit question, first thing you're going to do is plug it in, see what we get. Okay, so when I plug in -2, on top I get -8 plus 4 plus 16 minus 12 after I multiply and do all the powers and everything. The bottom I get -8 plus 32 minus 40 plus 16. So now I got to add and subtract. Last thing to do, add and subtract. So I get -4 plus 4, which is 0 on top. I get 24 minus 24, which is 0. 0 over 0. That means I can use L'Hopital's rule. If you don't get 0 over 0, you can't use L'Hopital's rule. If I get a number over 0, I can't use L'Hopital's rule. If I get 0 over a number, I can't use L'Hopital's rule. But since 0 in both places, so this one, to find the derivative of this one's not that bad. So I'm just going to use the power rule. I get 3x squared plus 2x minus 8 on top. Okay. Plug in -2 one more time. Okay, so -2 squared is 4 times 3 is 12. Minus 4 minus 8. On bottom is another 12 minus 32 plus 20. Twelve minus 4 minus 8 is 0. 12 minus 32 is -20, plus 20 is 0. I got 0 over 0 again. Use L'Hopital's rule again. Find the second derivative now. And keep doing that until I get an answer, until I get something I can use besides 0 over 0. So we get -12 plus 4, which is -8. Then I get -12 plus 16, which is +4. Mm-hmm.
Isn't it 2 up top?
2 up top.
6 -2 plus 2, and then change it to 12 plus 4.
So this part right here?
Yeah.
So multiply this, I get -12, right? Oh, sorry, plus 2. Yeah, that's what you're talking about. Yep, you're right. That should be a 2. So that should be -10. -10, yep. So that's going to reduce to -5/2. Done. Finally got an answer. Okay. Again, the thing that took the longest about this was just PEMDAS. You guys have been doing PEMDAS forever. You know, ever since you learned what the word PEMDAS was, or GEMS, whatever your teacher taught you back in elementary or junior high. Okay. That's really how to do it. I'm going to give you different problems. I gave you, so number 4 is a trig problem. Number 5 is a little different, but Number 6, you got some e's in there. Number 7, trig. But essentially, it's the same thing. Okay? So try number 4. Do number 4. I know it's trig, but you have your tables. You can use your tables if you need. Okay? So try number 4, and we'll go over it in a few minutes. Okay, so plug in 0 everywhere. Sine of 0 is 0. Cosine of 0 is 1. So 2 times 0 minus 0 on top, which is 0. 0 minus 0 times 1. 0 times 1 is 0, so I get 0. 0 over 0. Okay? L'Hopital's rule. So the top has 2 parts. Two times sine of x. So the derivative of sine of x is just cosine of x. So 2 times cosine of x minus. Now the orange part, I'm going to have to use chain rule for that because it's not sine of x, it's sine of 2x. So the derivative of sine is cosine times, inside, the derivative of 2x is just 2. Okay. Now the bottom, I have just regular sine of x and x times cosine of x. So the derivative of the yellow is just regular sine of x. So that's going to be cosine of x minus. Now x, it's x times cosine of x. X is a function, so they're being multiplied together, so I have to use product rule. Okay, so I'm going to put these in, because all of these go together. So product rule says the first times the derivative of the second. The derivative of cosine is negative sine plus the derivative of the first, which is 1, times the second. Okay. Plug in 0. Plug in 0 everywhere we see an x, I'm going to plug in a 0. So everywhere I see a cosine of 0, it's going to be a 1. One. So this is 2 minus 2. We have 1 minus, okay, so this part here is going to be 0. This part here is going to be 1. So we're going to get 0 over 0 again. 0 over 0 means we still have work left to be done. So I'm going to go back to where I left off and do the derivative of that. Okay, so go piece by piece. Again, just like I did last time. Go piece by piece. So I'll find derivative of that, derivative of this, derivative of this, derivative of that. So the derivative of the blue, 2 times cosine. The derivative of cosine is just negative sine. So it's going to be negative 2 times sine of x. The orange, I'm going to have to use chain rule again. So it's going to be 2 times the derivative of cosine is negative sine, 2x times the derivative. Derivative of the yellow is negative sine of x. Minus. Actually, inside here, I have 2 parts. So 2 different parts there. So I got to find the derivative of each of them. So the first pink part is x times negative sine of x. Product rule. So the first times the derivative of the second, the derivative of negative sine of x is negative cosine of x. Plus the derivative of the first, x, times negative sine of x. So negative sine of x plus. And then the derivative of the second pink is cosine, so that's negative sine. It's a lot, but you have a bunch of sines and cosines. So we're going to plug in 0. So you're either going to get 1 or negative. You're either going to get 1 or 0. When we plug in, oops, when we plug in 0, let me see, let me do it over here. Negative 2 times sine of 0 is 0, because sine of 0 is just 0, minus 2 times 0 times 2 is 0. Negative sine of 0 is just 0. So it's going to be 2 times 0 times 2. Let's look at the bottom. Negative sine of x is put in 0, you get 0 still. So we get 0. 0 times cosine of x is 1. So we're going to get 0 times negative 1. And then we're going to get 0 here and 0 here, right? So on top, we're going to get 0. On bottom, we're going to get 0 too, right? Now, for time purposes, I'm not going to keep going because I want to go on to the next thing. But you would take the derivative. Now, it's rare that you have to find the third derivative. It's rare. Like rare meaning you'll maybe see it once. Most of the time, it's first derivative or second derivative, you'll be done. Okay? But like I said, you might have one problem where you need to find the third derivative, the fourth derivative. They usually involve sine and cosine stuff because they just repeat themselves, right? The derivative of sine is cosine. The derivative of cosine, negative sine. But yeah, you would keep going. Okay? But I want to get to number 5, so I'm not going to worry about that. Okay, so number 5. What's the difference between number 5 and then the ones we've done, number 1 through 4 and number 5? What's the difference between them? There's one difference. It's to infinity, right? It's the limit as x is getting bigger and bigger and bigger and bigger, so big that I can't even put a number to it. We actually did these problems last semester. You had problems like this on your tests last semester. Does anyone remember what we did anytime we have x approaches infinity or negative infinity? Bottom heavy, we looked at 3 options, right? Is it bottom heavy? Is it top heavy? Or are they equally distributed? So buried somewhere deep in your notes. It depends how organized you are, but if you have, oops, that was wrong. Okay. This table here, it's one of the limits to infinity. Okay? Anytime we're approaching infinity, anytime the limit approaches either positive infinity or negative infinity, we have 3 options. Top heavy. Top heavy means the degree on top is bigger than the degree on bottom. The opposite is bottom heavy, the degree on bottom. The degree is the power, the biggest power. Okay? Equally distributed means the degrees are the same. Exactly the same. So let's go back to the one that we had. We're looking at. What is the degree for the top, the numerator? 2. What is the degree for the denominator? 2. Equally distributed, right? So when these are equally distributed, we said it's a fraction of the leading coefficients. The leading coefficients, the leading guys, are the ones with the degrees. The coefficients are the numbers in front, 3 and 2. So a fraction of those would be 3 over 2. That's your answer. That part, we're not changing. I'm not changing that part. I'm not changing that part. That part is going to be the same as last semester. Anytime you see limits to infinity or negative infinity, do what you did last semester. Bottom heavy, top heavy, equally distributed. Okay? Let's skip ahead to number 8. Look at number 8. Because number 8 is another one like that. Is this guy bottom heavy, top heavy, or equally distributed. It doesn't have powers, right? Or it actually does. The bottom does have a power, right? So I can rewrite the bottom as so the bottom has a power, the top has natural log. So right above this part was a growth rate. Which grows faster? The top grow faster. So factorial, exponential, those are the fastest growing ones. The ones that grow the slowest are constants because they don't grow. So let's look at this one. The top is a log, right? Natural log. That's right here. What is the bottom? Where does the bottom fit? Is it exponential? Is it a polynomial? It's not a log. So which one of those is it? Is it exponential or is it a polynomial? How do you know if it's a polynomial? If it's a polynomial, it has a power. X to some power. Doesn't matter what the power is, but it does, right? It has a power. So this guy is actually a polynomial. Exponentials are when the power is, if I had something like this, that's exponential. If the power is up top. If the power is a number, polynomial. Okay? So we have a log on top and a polynomial on bottom. The polynomial is going to grow a little bit faster. So that means it's going to be bottom heavy. Bottom heavy. Bottom heavy, the limit is always 0. Bottom heavy, the limit is always 0. That's just review. I'm not giving you any new rules or anything. That's just review from first semester. Okay? Because let me write this down. Because this guy is a log. This guy is a polynomial. Polynomials grow faster. So the bottom is going to grow faster than the top. If the bottom grows faster, if it's bottom heavy, it's 0. If it's top heavy, it's either going to be positive infinity or negative infinity. That's going to be your answer, depending on if it's a positive number or a negative number. Okay? All right. So we have a couple more we'll do tomorrow. There's an E problem that I want you to do. There's another tangent. Oh, here's another one here, number 9. We'll do that tomorrow, though. So we'll finish this tomorrow, and then I'll let you work on the practice, and that's it. We'll go on from there. Okay?